In this lesson, we're going to continue to work on explaining the meaning of derivatives. That's what I asked you to do in problem number 1, which is, again, a tiers per minute type of problem, tiers for working on calculus problems. So we have b prime of 5, and the work we're going to do is making meaning out of b prime of 5. So what does that mean with respect to this idea? Hopefully at this point, b prime is mostly negative for you, meaning your number of tiers is decreasing as time goes on. To facilitate that, what I'm doing here is really backwards from the way that most calculus teachers do this. What we're going to do today is I'm going to show you how to do this on your calculator. So these symbols here are the symbols your calculator uses to represent a derivative. And the work that you're going to do, the human work, is just the interpretation. So that's really what we're focusing on, with the added step of pulling the number off of your calculator. Most teachers would make you do this by hand a bunch. I will teach you how to do this by hand, but only after I'm satisfied that we know why we're doing what we're doing and what it means. Okay, so b prime tells us automatically we want a derivative because that's what the prime means. And on your calculator, let me show you what this looks like, and then I'll show you the button. So this is how we would represent this particular question on our calculator. So this d dx represents the derivative. It means the same thing as b prime. And then we tell it x equals 5. Okay. The keys for this, it's called the n derivative function, and the keys for this are math and then the number 8. Oops, let's clear this. So math, and then notice number 8 is n derivative. You can hit that, or you can just hit math and then the number 8, and then I'm going to use the x button to tell it I'm talking about x. We're always going to use x in here, so you're always going to do that. And then I'm just going to type in that function exactly how it looks. So 16 is easy, but the rest is a little bit uglier. So 16, and then E is the second ln button, e to the x. Nope, just kidding. E to the negative 0.4x. And notice I used an x and not a t. You're always going to use x because that's what I told our calculator to look for. And then we want x equals 5. That's what b prime of 5 means. So we're going to put a 5 here. And then that's your derivative. So 0.866. And you're going to keep 3 decimal spots because that's what's required in the AP exam. We're not doing significant figures or whatever. And this number has a name, and it's b prime of 5 is 866. So again, we got that number off of our calculator. You're doing the work of interpreting. So we're going to use our number unit time interpretation, and you're probably at the point where you can write that on your own. I'll give it to you in a few seconds so you can check. So here is my interpretation. So I have my noun, my unit, and my time. Noun at time. Number of tiers is increasing at a rate of, because it's a derivative, 0.866 tiers per minute at t equals 5 minutes. So that is essentially the whole lesson, but I do want to tackle a slightly more challenging problem and show you a really useful shortcut on your calculator. So in my second problem here, we're giving up on calculus and we're going to Six Flags. And we have 2 questions to answer, and we have 2 functions. We have E and L, entering and leaving. This is really common FRQ style question to have 2 functions like this and multiple questions about these 2 functions. The 2 questions I gave you, one is very easy, E of 6, and then one is a little bit harder. Is the rate at which people are entering the park, and you'd want to annotate that, increasing or decreasing at t equals 10? Then we're asked to justify our answer. Okay, so what we should notice is both of these have to do with the function E, so we don't care about L at all right now. So we can disregard that completely. And because I know I'm going to use E twice, I want to save myself the work of typing in this whole thing in my calculator more than I have to, right? So that's a lot to type in. We got to do the fraction bar. It's easy to make a mistake. We want to avoid that if we can. So we're going to type it in just once. And look where I typed it in. I typed it in the y equals screen where we used to graph equations, right? And then I just typed it in exactly as I see it, again with an x instead of a t. And you guys know how to get the fraction bar. It's the alpha button and then y equals, like that, numerator over denominator. And then once I've typed it in, I can use it to answer both these questions without typing it in again. So first question, E of 6. means what it always has. So e of 6 means just plug in 6. So I'm going to do second calc value is an easy way to do that, and we've done this before. And then just plug in 6, and your calculator is going to spit out 300. So I'd make sure you can reproduce that. And then notice we did not take a derivative there because it didn't tell us to. It told us to plug in 6. So our interpretation is not going to be necessarily the same as we would say for a derivative, right? So we could say at t equals 6, so there's my time, t equals 6 hours, t hours after midnight. Okay, this here, people per hour, t hours after midnight. I don't have to change my unit here because I didn't take a derivative, right? At t equals 6 hours, people are entering the park at a rate of 300 people per hour. And that's exactly what it was in the problem, right? So I didn't change anything because I didn't change e. I left it alone, right? So I didn't take a derivative. So that's my interpretation. Notice it still reads the same, even though we did not take a derivative. Now, B is a new type of question. And the question is whether the rate, so the rate, remember, was e, is the rate increasing or decreasing? Is the rate increasing or decreasing? Another way to say this question is the slope of e positive or negative at t equals 10? Right? Or is the derivative positive or negative at t equals 10? So to answer this question, I need to take the derivative of e, plugging in 10. And remember, we saved e as y1, so we don't have to do all the work of typing it again. So I'm going to get out of my grapher. I'm going to do math 8, still put in an x, but instead of retyping it in, I'm going to hit this vars button, variables, right here next to clear, go over here to function, and here I have a list. And y1 was my e, right? So we gave it a name so we could find it later, and then we're plugging in now 10. Good. So that spits out a positive number. Okay, so I'm going to record that value. So I'm going to say e prime of 10. And if you're anything like me, you forgot what that number was as soon as I clicked it off the screen. And then this is okay to round up because notice it's 0.99 past 3 digits. So I'm allowed to round that, 156. So e prime of 10 is 156. I don't have to give units or anything because this is not my claim anymore. This is my justification. So I can say that the rate is increasing because the derivative is positive. So e prime of 10 is greater than 0. You should say 10 right here because it shows that you know what you're talking about. And really all we're saying here is the slope is positive. Okay, so that's my shortcut, and here's like a slightly more challenging problem that I'm going to throw at you a little bit in your next assignment. The shortcut one more time. We type it in and we hit vars, go over to yvars, and then hit function, and that gives us a list where we can plug it back in. So hopefully you're starting to see why this calculator is so expensive, because it's so useful.